Hello, I'm Ulrich Lang. I'm the CEO and co-founder of Object Security. I'm presenting RedBox, a technology for automated embedded systems vulnerability assessment. The original SBIR topic is Red Team in a Box for embedded and non-IP devices. Object Security is the security automation company. We simplify, improve, and automate security for the complex interconnected IT landscapes most organizations have to deal with nowadays. So when we say security automation, we focus on security policy automation, supply chain risk analysis automation, and vulnerability assessment and pen testing automation. We're a small business in San Diego with a great government and commercial track record and great R&D and commercialization successes. Email us at info@objectsecurity.com or check our website at objectsecurity.com to see more details about the other products. But this presentation focuses on vulnerability assessment and pen testing. According to the SBIR topic description, the Navy's challenge is that embedded systems are not assessed at scale for unknown software vulnerabilities. And that's because there are currently no tools available that are portable, automated, easy to use, non-destructive, can be used by non-experts, and can be used on already deployed systems. The Navy needs such a tool. Existing other tools are often geared for experts, require a cloud service, and are often focused on network vulnerabilities or previously known vulnerabilities. Embedded systems are particularly challenging because they're often already deployed and they cannot be physically removed very easily. There's no screen and keyboard usually, and logins are often unknown. Device internals are unusual or unknown, right? So today, this assessment is done by hiring experts that will break into the device, extract the firmware, analyze it, and create a report. That clearly doesn't scale, and hence the rationale for this SBIR topic. So just to recap the operational need and improvement here, the Navy needs to assess embedded systems at scale for cyber vulnerabilities, including already deployed embedded systems. What that means is that non-experts need to be able to carry a RedBox device on board, plug it into embedded systems, and when the automated assessment is done, view a simple report, like a traffic light report about how vulnerable the embedded system is. So as I said, that means the device needs to be a portable software vulnerability assessment device. Non-experts can use it to support scale, needs to be mostly automated to support scale, needs to be able to, it needs to be possible to carry it around on a site. So that also means it may need to be battery powered, connect to an embedded system via common connectors. And it's supposed to support unknown devices, unknown software, unknown vulnerabilities. So it needs to detect all of this and handle it. It needs to be non-destructive, so no unsoldering of the chips on the board and so on, right? And needs to be offline, so it doesn't need to require internet. That's pretty much the requirement statement, if you will. So we already have a working prototype of the solution, and it does pretty much what I just described. So a non-expert can carry a RedBox device on board and plug it into an embedded system. RedBox then automatically assesses the embedded system, and the user can view a traffic light or an advanced report. Like I said, portable device, non-experts can carry it around, connect to already deployed embedded systems via common connectors such as terminal ports, USB ports, UART and JTAG and so on. So it does produce a list of CWEs. These are MITRE common weakness enumerations. So that's kind of a classification of types of software weaknesses. It's automated, can be battery powered, and works non-destructively. And it does not require internet to run. So the process is basically to connect, then to extract. That's mostly automated, except the user has to kind of plug and unplug stuff. Analyze, that's fully automated. Report means you look at the report, so there's nothing much to do. It's traffic light colored. And then to adapt is another goal, to learn over time what works and what doesn't. So this is what the tool automatically does. That is a different approach from what typically is done, which is often SaaS products are used, or it's done manually by experts. And often there's focus on network vulnerabilities rather than the actual firmware, the software of an embedded system. We have also commercialized a first build of the engine, which you can go to at easyvapt.com. So it's easyvapt.com if you want to just try it out. It lets you upload a couple binaries and gives you the CWE results in a traffic light score. The current state of this is that we have developed a minimum viable product, an MVP, actually end of 2020, early 2021. So has been demonstrated to the Navy, which supports 3 different kinds of connectors. They're actually a little different from what we had on this slide deck. So we use a console port, micro USB, console port from an RJ45 and USB, and also a UART internal port on the board. We're currently working on adding more connector types. There's also a number of assessments that get automatically run. Pretty much that list that you can see on the right. So these are all open source tools, and there's a number of others that have been added since then. They're all automatically sequenced in an efficient way to provide those results. So there's quite a lot running in the back end that you would need to do manually otherwise. So there's a pretty significant efficiency gain here through the automation that this tool offers. So to add to the current state, we've been fully funded in this SBIR, including a contract mod to bring the whole amount to 2.5 million. And we have quite some way to go, another year and a half. There's a whole list of stuff. And frankly, that list has somewhat changed. So I'm not going to go through it in detail. What's important is we're going to, and we are already working significantly to improve results better than the competition, using a lot of machine learning and more tools, better tools, orchestrating them faster, and so on. We're also working significantly on the connection and extraction piece, which we find very challenging, remains challenging to automate that. So we have many ideas, and there's a lot of progress expected there. We're also working on systemic analysis, where we look at data in a bigger picture, and so on. So I'd say email me if you want to know more about what we've planned. For the programs of record, I think what's important is that this doesn't have to just be one tool out of many that people use somewhere, but it could be used as a, if you will, triaged tool where when an embedded system comes into a test center, this would automatically provide a first level of traffic light type results that allows testers to focus on or to figure out what to focus on. So that's one nice use case. The main use case is obviously the one with the portable device. There's also the SaaS and development pipeline integration that are all that we're all pursuing. So our technology is built modular to support pretty much all of those and other deployment scenarios. Much of the remaining focus is going to be about improving things significantly. There are many tools out there for binary analysis, and the question is really who can get the best results quickest, and who can get to the binaries in the first place. So that's what we're resolving. Very exciting. The portable device flavor of our technology has the following key features and benefits. It automatically probes multiple interfaces to extract the firmware. We usually extract via USB because it's fastest. The extracted firmware is then analyzed automatically using numerous assessments, also for previously unknown devices. So you don't have to have an existing library that's supported. The results are aggregated and analyzed, and there's a user-friendly, non-expert UI, like a user interface that essentially shows you a traffic light score for each binary and an overall score, so you know how bad it is. It supports limited battery and time. That's a requirement for this portable device. It works offline, portable, and is non-destructive, as I mentioned. There's also a backend for full systemic analysis, which we use right now internally mostly, but that can be provided for an organization to look across all devices that were tested for the entire organization. That should be very valuable once you're looking at families of devices, or even the same kinds of devices, multiple instances of devices in different chips and so on. There's probably a lot of analytics that can be gained. So we support that already with a customizable dashboard and so on. So in order to transition this to the fleet, we really would need more test devices and pilot users and just people bringing requirements to us. So what do you really need? It's obvious that embedded systems are more vulnerable than they should be, and people don't have visibility. So how would you go about improving it? Where would this tool fit in? Please email us about that. We're on track to transition this into a full commercial product after phase 2. As you know, easywap.com is already available, and we're working on multiple other commercialization routes at the moment. So yeah, please contact us. We really need to know from you what you need in order to be able to deliver it. Thank you. We're in the middle of a major market analysis to ensure we have a viable product. It's clear that the RedBox is a horizontal tool, so it's widely applicable, both across the fleet and other industries. And embedded systems is the main use case, but it's also for IoT, ICS, and any other kind of microelectronics and computers and so on. So very widely applicable and should be made available widely across the Navy with the right assurances built in. There are many use cases and deployment kind of scenarios. We're looking at a server with a tablet, with a handheld, for example, to offload and increase performance. Some SaaS offloading, including network-based vulnerability assessments. The freemium SaaS is one of our commercializations that we already have at easywap.com. Please check it out. Also integration into development and deployment pipelines. That's where the market's pretty busy, but we can support that too. So it's interesting for us. An interesting other use case is to include a library of device knowledge for Navy-specific devices, so that you're better at analyzing, better at connection and extraction, and so on. So that's maybe interfaced with diagnostics workbenches and so on. Okay, so in order to transition, we may need a partner, either a program of record or a prime, to act as an internal shop front, unless the Navy is okay with us as a small business providing and maintaining the RedBoxes. It's really COTS hardware, so we're not a major manufacturer there, but still it will probably be good to have a partner. So if that's you, please reach out to us. We'd like to discuss how we could work together. We would also probably need follow-up funding. In order to get the last 20% of the product done, it's usually 80% of the effort. That's kind of common software engineering or just engineering know-how in general. So please, if you have funding and you need this, bring your requirements to us and we'll work with you. And then in general about the requirements, we need clear requirements, both about the device, what's the SWAP-C, what's the ATO requirements, and so on. Just want to avoid process hurdles. There isn't too much here because it doesn't need to be integrated per se, but it clearly needs some kind of ATO to be brought on a ship and plugged in somewhere. There's also just general process issues that need to be figured out, like which devices are actually okay to be plugged in while they're still fielded and so on. Any ideas here, please talk to us. We're very interested in your opinion, your feedback, anything really. We'd love to hear from you. In summary, the RedBox SBIR is for automated AI-supported vulnerability assessment of already deployed and new embedded systems for non-expert users. So to give you maximum security with minimum effort. Please talk to us. We really would like to hear from you. Any feedback, good, bad, anything. Try out our SaaS at easywap.com. Tell us your requirements. Tell us gaps of existing tools and what you would like to see, how you do things today, how you would like to do things tomorrow. Technical discussions, anything really. My email's right here. You can also read up on the website. We have some information, and contact us through the website or through my email here. Really thank you very much for watching this presentation. Hope it was enjoyable, and love to hear from you. Thank you.